Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So today, we're looking at past maths WAEC questions on sets and Venn diagram. So sit tight and enjoy our video. The first question we have here for today on sets is number 1 question from WAEC 2005, and it says, given universal sets U is equals to 1, 2, 3 up to 10. So in between 3 to 10, there is 4, 5, 6, 7, 8, 9. That is the universal set. That is this one. And A is given as 1, 2, 3, 4, 5. That's set A. And set B is given as 2, 3, and 5. Set C is given as 6, 8, and 10. Find A intersect C. First of all, you have A already given as elements 1, 2, 3, 4, and 5. And set C is given elements 6, 8, and 10. So A intersect C is what is present in A and at the same time present in C. So let's compare. I have 1 in A and I don't have 1 in C. I have 2 in A, I don't have 2 in C. I have 3 in A, I don't have 3 in C. I have 4 in A, I don't have 4 in C. I have 5 in A, I don't have 5 in C. So the same thing applies the other way around from C. I have 6 in A, in C, I don't have 6 in A. I have 8 in C, I don't have 8 in A. I have 10 in C, I don't have 10 in A. So the answer to this is empty. It's an empty set. Nothing is intersecting. No element is common to A and C. So this first one is null sets. For number 2, we're told to find A intersect B prime. So I already have A, but what is B prime? B prime is elements that are in the universal set but not in set B. Set B already is 2, 3, and 5. So any other thing that is in the universal set and not in these elements or in this set is B prime. So 1 is not in B, but it's in universal set. 4 is not in B, but universal set. 6, 7, 8, 9, and 10. So these are elements that are universal sets but not in B. So if we check again, I don't have 2 in this set. I don't have 2 in this B prime. I don't have 3 in this B prime. I don't have 5 in this B prime. So this is correct like this. But we're asked to find A intersects B prime. So I will come and list all the A again from what I have here. I'll list all what I have in A. I have 1, 2, 3, 4, and 5. So I'm asked to look for the intersection. So 1 is common. I can circle it like this. 1 is common, the two of them. Which other one is common again? I have 4 is common. 4 is common. I'll link them together like this. What else is common? Okay. So after checking, A intersect B prime is 1 and 4. That's the only one that is common. 1 and 4 is common, right? Okay. So the next question is number 2 from WAEC 2020. It says, given that A is a set of elements multiples of 2. So I have A is equals to multiples of 2. As in 2, 4, 6, and so on, right? A 8, then 10. Okay, I'm stopping at 10 because I'm just seeing that the universal set is between 1 to 10. Okay, so B is multiple of 3. So it is 3, 6, then 9. Okay, so we stopped at 9 because the universal set is 10. And C, factors of 6. Factors of 6 is 6, right? 6. Okay, so find A intersect B intersect C. Okay, so what that means is that you look for an element that is present in all the sets. So these are elements. Elements in A is 2, 4, 6, 8, 10. Element in B is 3, 6, 9. Element in C is 6. So you see that 6 is common to the three of the sets. So 6 is the intersection of set A, B, and C. Okay. So this one, he said in a class of 60 students, 30 offer maths, 40 offer physics, 10 offer both. Find number who offer neither. So I can just quickly use a Venn diagram to do this. So if I have the Venn diagram that looks like this, so universal set is 60. This is a class of 60 students. So I have maths and physics. So M math is 30 and P physics is 40. And we said 10 offer both. So 10 is the intersection. So find the number who offer neither. So that neither, N, is outside. Is outside, right? So I can write the formula like this. All right. I'll say universal set U is equals to M, number of M, plus number of P minus number of M intersects P and plus capital N, neither. Okay, universal set is 60. Number of maths is 30 from this diagram. Number of physics is 40 minus intersection of math and physics is 10 and plus N, neither. All right, so I have 60 is equals to 30 plus 40 is 70. 70 minus 10 plus N. So I have 60 is equals to 70 minus 10 is 60 plus N. So this will go here. So I have N is equals to 60 minus 60, which equals to 0. So we don't have anybody that study neither. So 0 students study neither. So we have this 2016 question. It says 95 travelers surveyed. 7 used bus and train only. 3 used car. 3 used train and car only. 8 use all 3. Bus total is 47. Train total is 30. Let bus and car only be X. Box only X. Find X. Okay, so from here, we know that we are seeing 3 different modes of transportation: bus, train, and car. So B is for bus, T is for train, and C is for car. So let me just draw another Venn diagram here, just to represent what we are talking about here. So I have bus, train, and car. So bus is B, train is T, car is C. So it says 7 use bus and train only. 7 use bus and train only. So bus and train, I put 7 here. Okay, so I have 3 use train and car only. 3 use train and car only. Then 8 use all 3. So 8 is center here, all 3. Then total for bus is 47. So I put 47 here. Then total for train is 30. So I put 30 here. Then I have let bus and car only X. Bus and car only. So I have X here. Bus only is another X here. And find X. So this is what I am looking at. This particular set. So I can bring it out separately and say bus is equals to 47. Is it 47? Yes, 47. Then I have um, something like this. Okay, sorry. I want to bring it out so that you can know. So this is 8 here, this is 7 here, then this is X here. This is X here. If I sum all this, it will give me 47, right? So I will say um, 47 is equals to this X plus 7 plus another X plus 8. So I have 47 is equals to X plus X is 2X, 2X plus 8 plus 7 is 15. That's 15. So 15 comes here. 47 minus 15 is equals to 2X. All right, so this is 2 and 3 is equals to 2X. Right? So X will now be 16. Why? Because 32 divided by 2 is 16. So X is 16. Okay, so this is 2012 question. It says 2/3 travel by road, 13 over 30 by air, and 4 over 15 by boat. 20 travels by neither. Find total number interviewed. So, okay, this question is just like a summary. I think what it's saying here is that total people were interviewed on how they travel. Okay, let me just draw a Venn diagram quickly. I like to use Venn diagram. So, total number of people were interviewed by how they travel. So, I can see road and air, boats and neither, right? So, I think there are only two modes of transportation here, road and air. So, roads and air. So this is road and this is air. Okay, so it says to travel by road. So to travel by road, so road is 2 over 3 of the total number. Okay, let's call it that over total number n, for instance. Total number of people interviewed. Let's call it n. So two-third of that total number, is by road. Then by air is equals to 13 over 30 of that number is by air. Then 4 over 15 is by boats. 4 over 15 of that number is boats. Then for the first time, we have a whole number travel by neither. So there'll be 20 outside here. It's a prime complement. So find the total number that travel. So the formula is the universal set total number n is equals to the number of people travel by road can come here plus number of people travel by air minus the intersection number of arrow intersects air and plus neither. neither. So I can call that neither x, though neither is given as 20. So let me just put it there as 20. Okay, so I can now say n is equals to, number by road is 2 over 3n, right? Plus number of people by air is 13 over 30n, minus the intersection is 4 over 15n, and this 20 is neither. Okay, so I have this equation that will solve for n, which is going to be very easy from now on. So I'll just watch this. Let me take it off to this side. Okay, so first of all, I will get the LCM of uh, 3, 30, and 15. I'm going to work on this fractional part. Yes, let me work on it here. 2 over 3 plus 13 over 30 minus 4 over 15, all n. So what is the LCM? The LCM here is still 30. So 3 into 30 is 10. 10 times 2 is 20, plus 30 into 30 is 1. 1 times 13 is 13. Then minus 15 into 30 is 2. 2 times 4 is 8. Okay. So I have 20 plus 13. That will give me 33. 33 minus 8 will give me 25. That's 25 over 30 n. So I'm going to put that in all of this place. So I'll say n is equals to 25 over 30 n and minus 20. So at this point, I'm going to subtract both sides. This one will go over to this side. So I can take this off, erase this, so I can continue. Okay. So n minus 25 over 30 n. So I'm going to solve this in a bit. I'm going to solve this in a bit. Okay. So I'll solve this in a bit. Um, the LCM, the LCM of this is 30. We're taking this one as 1 over 1, right? So 1 into 30 is 30. 30 times 1 is 30. Minus 30 into 30 is 1. 1 times 25 is 25. All n outside. So 30 minus 25 is 5 over 30 n, right? So I can reduce this one to 5 here 1, 5 here 6. So that is 1 over 6n. That's what this one is. Okay. So having gotten this difference, n minus 25 over 30 n, as 1 over 6n. So I can come here. Oh, this is going to be a plus because there's a plus here. So I can come here, I will say 1 over 6n is equals to 20. So I can multiply both sides by 6 to get n. So when I do that, it will be n is equals to 20 times 6. So this should be 120. So the total number of people interviewed is 120. N is equals to 120. 120. That's n. Okay. So that's the answer. Okay, number 6, it says if number of A is equals to 7, number of B is equals to 16, and total is equals to 20, find number of A intersect B. So number of A union B is equals to number of A plus number of B minus number of A intersect B. This is the formula. Okay, so we have the question. The total is 20. The number of A intersects number of A is 7. Then number of B is 16, and number of A intersects B, let's call it X. So once we have gone to this point, every other thing is equation. So X will be giving us 3. So question 7 says define finite set, infinite set, and empty set. So these are terminologies that we use in set theory. So infinite sets or finite sets has limited elements. E.g., if I say a set has elements 1, 2, 3, and I stop there. So because of the limitation or the stoppage of the listing of this element, I can call it a finite set. It's definite. I can define it by 1, 2, 3. Nothing outside this is defined by this set. But an infinite set has endless elements in it. So if I come and just type, say, natural numbers, you know that natural numbers you can continue to count without limitation. So an empty set has no elements. So that's the symbol. I think I've used this symbol for one of the questions, previous questions in this video. So it means 0, empty, nothing inside the element or inside the set. So question 8 says if A is defined as 1, 2, 3, elements 1, 2, 3, and B is elements 3, 4, 5, find A union B. A union B is the summation of the two elements without repeating anyone. So A union B, you list it as 1, 2, 3, 4, and 5. Notice that 3 appears here and here, here and here, but we are not listing it 2 times. We list it once because it's just a listing of those sets, those elements. So that's for the first question. Second question is A intersect B. Intersect B, A intersect B means that what is present in A and I set are present in B. So I have only one element, and that element is 3. All right. So given the universal set, number 9 now, U is equals to 1 to 10. That is like this. List it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? And A is given as 2, 4, 6, 8, according to the question, right? Find A complement or complement of A. What that means is that I will look at these elements already listed here and exclude them from the universal sets and list out the remaining sets after the exclusion. That will form a complement. Okay, so practically I can say I have a 2 here. So I have a 2 here. So I strike it out. I don't need this one. I have a 4 here. I have a 4, I strike it out. I have a 6 here. I have a 6, I strike it out. I have 8 here. I have 8 here, I strike it out. So what is left is the complement. That is 1, 3, 5, 7, 9, and 10. So what is not in A but in the universal set is known as A complement. Question 10 says number of A union B is equals to 50. Number of A is 30. Number of B is 25. Find number of A union intercept B. So again, the formula is okay. Is A union B. Number of A union B is equals to number of A plus number of B, then minus number of A intersect B. This is the formula for it. So that's how I have number of B, A union B is 50 is equals to number of A is 30, number of B is 25, and A intersect B is X. That's this one. So 50 is equals to this, and this is 55 minus X. When this one goes this way, it now becomes 50 minus 55 is equals to X minus X. So 50 minus 55 is minus 5, so minus X. And X is equals to 5. So the number of A union intersect B is 5. So this is WAEC 2002. Okay, so I'm given A as 1, 3, 5, 7, 9, 11, B as 2, 3, 5, 7, 11, 15, C as 3, 6, 9, 12, and 15. Universal sets is given as 1 to 15. Find C intersects A prime. So the first thing we'll do is to list universal sets. So universal sets is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. All right, this is well listed. So I'll use this one as my A and B and C. But they say A prime, I'll list A prime. A prime is, I'll check what is in A and not in the universal sets. So I see that I have 1, I have 3, but I don't have 2. I have 5. Sorry. Let me list A first. So let me just list A out first so that I can use it here. So the A from the question is 1, 3, 5, 7, 9, and 11, right? Okay, so now I'm going to be striking off. I want to generate A prime. So A prime is what's not present in A, but are in universal sets. So I will strike out the what's present here. So A is here, 3 is here, 5 is here, 7 is here, 9 is here, 11 here. Okay, so what is left now is 2, 4, 6, and 8, then 10, then 12, 13, 14, and 15. So this is A prime listed. So let me just put the brackets as A prime listed, right? So they say we should find C intersects A prime. So what is C from the question? C from the question is 3, 6, 9, 12, and 15. So what is the two of them? Okay, so I have these two. Okay, I have 12. I have 15. So C intersect A prime is 6, 12, and 15. Okay, So that's for this first one. Then A prime intersects B union C. Okay, so let me take this off. Let me take everything off and solve for number 2. So number 1 is given as what I have here, 6, 12, and 15. That is C intersect A prime, 6, 12, and 15. First of all, get what A prime is, then, you know, do intersection between A prime and C. All right. So the next thing is to write out A prime again. A prime, A prime is given as what is not in A but in universal sets. So I have what is there? I have 2. I have 4. 2, 4. I have 6. I have 8. I have 10. I have 12. I have 13. I have 14, and 15. Right? That's for A prime. So, but B intersects, sorry, C is what is in B and C together. So I have 2 and 3 and 5 and 6 and 7, 9 and 11 and 12, then 15. So the question is A prime intersects B union C. So is this 2? I want to find their intersection, right? So first of all, 2 is common. I put 2. What's common again? 6 is common. I put 6. What's common again? 12 is common. I put 12. 13 and 15. So that's the answer for this. Okay, in a survey of 80 students, 45 like maths, 40 like English, 25 like both. Find the number who like neither. Who like neither. Okay, so this is the formula. Uh, 80 students. So it is number of universal sets is equals to uh, number of maths plus number of English plus minus number of maths intersect English, and plus neither. See how my organization. Now the um, number of universal sets U is 80. Number of people who like maths is 40, 45. Sorry. Number of people who like English is 40. The number of people who uh, like both is 25, and neither is n. So you see that neither is standing alone. We can now solve uh, using the equation to find the unknown n. So at this point, I will say 80 here outside is equals to 40 plus 45 minus 25 will give us 60 plus n, and n is 80 minus 60. N is equals to 20. So 20 people like neither subjects. Okay, so 13 says given universal sets U is equals to 1 to 20. A is multiples of 2 and B is multiples of 5. Find A intersects B. So multiples of 2 is given here for A. Multiples of 5 is given here for B. So intersection is what is common to the two of them, right? So I can see that 10 is common, 20 is common. What else is common? Okay, I think 10 and 20 are called the common elements, right? Now for question 14, it says number of A is 25, number of B is 20, and A union B is 35. Find number of A intersects B. A intersect B. A intersect B. Okay. Now A union B, formula A union B is equals to number of A plus number of B minus number of A intersect B. So this is just formula. If there's a neither, you put the neither as a plus. Understand? But there's no neither here. So if A union B is 35, number of A is given as 25, number of B is given as 20, and the number of A union B, intersect B, let's call it X. So I'll say minus X. So at this point, I will say 35 is equals to 45 minus X. So X comes here, 35 goes here. So it is X is equals to 45 minus 35. X is equals to 10. So number of A intersect B is 10. Is 10. So in a class, 20 students take biology, 18 take chemistry, 5 take both. Find number who take only one subject. Find number who take only one subject. Okay, so right now we don't have the in a class. Okay, 25. We don't have total number of students, right? Okay, so only biology. Only biology is 20 minus 5. Why? Because there is a boat inside that 20. So only biology is 20 minus 5. This 5 is taken away from 20. Why? Because those 5 students take both biology and chemistry. So if you take 5 from 20, you get 15. So only biology is 15. For only chemistry, is 18 minus 5. If we take 5 away from 18, you will still get 13. By the time you add the only biology and only chemistry, you will get 15 plus 13, which is 28 students. Now, these are letters. Number 16. Given capital A as the vowel sounds A, E, I, O, U, that are the elements that makes up capital A sets. Capital B sets, the elements that make them up is little a, B, C, D, E. Find A union B. Union is you are going to list out the elements that are in both of them. Yes. So A union B is equals to, so I'm going to list out all the elements in the both of them. I have A in the both of them. I have B in the both of them. I have C. I have D. Yes. I have, without repeating, okay. I have E. I have I have O, and I have U. So this is A union B. For intersection, I'm going to be taking what is common in the two of them. So A is common in two of them, and E is common in two of them. A and E common. So intersection is A and E. So define complement of a set and give example. So complement of a set is element in universal set but not in the set itself. So example, this is a universal set U. And if I have A as defined as 1 and 2, elements 1 and 2, A complement is 3, 4, and 5. Why? Because 3, 4, and 5 are not in A, but an universal set. So the complement of a set are element universal sets. This A 3, 4, 5 are universal sets already, but they are not in the set A. So that's an example. It's a simple example that defines complements of a set. Okay, so if the number of universal sets is 100, number of A is 60, what is A prime? A prime, number of A prime is 40 already. Why? Because universal set minus 60 will give me 40. If A is 1, 2, 3, 4, B is 3, 4, 5, 6, find A union B prime given find A union B prime given universal set as 1 to 6. 1 to 6. Okay, so universal set is equals to 1, 2, 3, 4, 5, and 6, right? And A union B is 1, 2, 3, 4, 5, and 6. So A union B prime is, as complement of A union B, is what is inside the universal set but not in this set. So this is 0. 0. Empty set. It's an empty set because everything is present. 21. WAEC 2018. It says in a class of 120 students, 65 offer mathematics, 70 offer English, 50 offer both. Find number 1, number who offer at least one, and number 2, number who offer neither. Okay. So if we have number of A union B is equals to number of who study only maths plus number of who study only English minus number of who study both. By the time you do this maths, this and this will give us 85, right? But you know we have 120 somewhere. So if you subtract 120 from 85, sorry, 85 from 120, you will see number who offer either or neither. So that's the answer for number 2. In a survey of 90 people, 55 like rice, 45 like beans, 20 like both. Find number who like only rice and only beans. Okay, so 90 people, you have 55 like rice, 45 like beans, 20 like both. Only rice is 55 minus 20. You take away the 20 from 55. 20 is the both. So only rice is 35. Only beans, take away 20 from 45. You get 25. 2009 question. It says, given universal sets, U is equals to 1 to 15, A multiples of 3, B factors of 12. Find A intercept B. So you list out these sets. Sometimes they define the sets by a rule, set rule. Understand? These are set rule. This is a rule. This is another rule. This is another rule. So you list out the numbers so you can see very well. So the first one, multiples of 3. Understand? Multiples of 3, factors of 12, and the common is you look for what is common in A and B. So this is A, for instance. This is A and this is B. So look at what is common. I have 3, 3 common here. I have 6, 6 common here. And I have 12, 12 common here. So that is the intersection. So 24 says if number of A union B is 60, number of A is 35, and number of A intersect B is 15, find number of B. Find number of B. Again, I have number of A union B is equals to number of A plus number of B, then minus number of A intersect B. So I'm given this one as 60, number of A as 35, plus number of B is unknown. I'm looking for it, but intersection is 15. So again, this is a an equation. So I have 60 minus 35 plus 15 is equals to number of B. So number of B will be 40. Okay, 25. It says in a group of 150 students, 80 take maths, 70 take chemistry, 60 take 70 take physics, 60 take chemistry, 30 take maths and physics, 25 take maths and chemistry, 20 take physics and chemistry, 10 take all three. Find the number who take none. Who take none. So this is the formula. This is the formula. Number of everything is equals to number of only A, B, and C, then minus. So you subtract intersection of 2 by 2 and add the intersection of every other thing. Okay, so if for instance I have a Venn diagram like this, this is 1, 2, and 3. So I have maths, I have physics, I have chemistry. So I will have the total number, which is U is equals to 150 here. Then I have for which is this one. So I have the number that takes mass as A, physics as B, and chemistry as C. Now I'm going to subtract the intersections of 2 by 2. So I will say I'll subtract intersection of this intersect this color here. I will subtract it. I also subtract, that's the first pair. I'll subtract B intersect C, second pair. I'll subtract M intersect C, third. So all the intersections 2 by 2, I will subtract them. Then I'll come and add the intersection of the three of them. So this is the formula for three sets that intersect, right? So I'm just going to put in the parameters. I'll put in the parameters. So for number of mathematics is 80. Number of physics is 70. Number of chemistry is 60. So for the intersection, just put minus, then open a bracket. 30 is intersecting math and physics. So math and chemistry intersection is 25, and chemistry and physics intersection is 20. Then all is 10. Okay. So I'm getting 145 as number of them that take everything. So if you are getting 125 from A union B union C, and the total number in a group is 150, so what do you think is the total number who take none of these three subjects? So it's going to be 150, which is the total group of students, minus 145, which is those people that participated in math, physics, and chemistry, one way or the other. That's 5, right? Okay. So question 26 says, given universal sets as 1 to 20, even numbers is A, and odd multiples of 3 is B. Find A intercept B prime. Okay, again, you're going to list out this element of set. U is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. A is even numbers 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Then B is multiples of 3, 3, 6, 9, 12, 15, and 18. Right? So find A intersect B prime. So I'm going to get a B prime, and B prime is what is universal set and not in this place. So I'm going to list them out. I have 1, I have 2, I have 4, I have 5. So I'm listing what's in universal set but not in B. I have 5. Sorry, I have 5. Yes. I have 7. I have 8. I have 10. I have 11. I have 13. I have 14. 14. I have 16, 17, 19, and 20. Okay, so this is what I'm looking at. This and this. Intersection means of these two elements or sets, what is present in both of them. So the first thing, I have a 2 common to the two of them. 2 is common. 4 is common. Okay. 8 is common. 10 is common. 14 is common. 16 is common. And 20 is common. So I'm going to list them out like this. This one is equals to 2, 4, 8, 10, 14, 16, and 20. So that is the answer. 2, 4, 8, 10, 14, 16, and 20. So it says 27 says number of A is 40, number of B is 50, and number of A intersect B is 20. Find number who are in exactly one set. Again, you will remove the intersection from each of A and B and add up. So remove 20 from 40, 20 from 50. This difference, first difference will give me 20, second will give me 30. If you add the two of them, I get 50. Okay, so a set contains all prime numbers less than 10. List the sets. State whether it is finite or infinite sets. So prime number less than 10. What are prime numbers? One that can define itself as 1. So I have 2, 3, 5, and 7. So finite numbers are limited elements. So this is a finite number or finite set. Why? Because I is not an ellipsis. It's not a continuous. I cannot continue to list this set. It's set that have stopped at a particular point. That's at 7, right? Okay. So the answer for number 1 is 2, 3, 5, and 7, and for number 2 is a finite set because they are limited elements. So 29 says if A belongs to C, this is read like this: A belongs to C or B. Sorry, what that means is that A is inside B, and number of A is equals to 5. Then number of B is equals to 12. What is B difference A? That is what inside B and not inside A. So it's just 12 minus 5, right? B difference A is elements in B but not in A. So the number is 7. So it says simplify. A intersect B union A intersect B prime. So you can you can factor this out. If you factor A out, so you factor A intersects out. So it comes out like this. Okay, let me just, it's already, the answer is already gotten here, but I want to explain. So it is A intersect B union A intersect B prime, right? So these are operations, actually binary operation, I mean set operations. So this is union, but this is A intersects is common here and here, right? So I can bring it out as a factor. I will say A intersect, open a bracket again, and put what is remaining. I have B union B prime. Now, A intersects. Anytime you see B union B prime or A union A prime, what you are listing is the universal set itself. Why? Because if I have B prime and B together, is the whole set I'm listing. Why? Because B is defined as element of a set, and B prime is elements that are not in B but are in universal set. So the two of them combined give me the universal set. So if I have A intersects universal set, it will give me A because I cannot go beyond A for intersection. Everything in A is inside the universal set. So intersect universal set is A itself. This is a very, very logical and simple concept that we have introduced at this last question. So I hope this video has been free for you. I'd like to thank you for viewing. See you in the next lesson. Thank you.